All right, it's week 1 Friday, so you guys got through your first week. Yeah. It's and we only have there's what 30 weeks in the school year. Well, and then maybe 33, right, if you count the finals weeks. So that's like a 3% completion bar, right? So it'll be over, and you'll be like, whoa, what happened? Okay, and then you'll long for the days you were in college. I didn't mean it like that. I just, you know. I love my job today, but you know, hey, being an adult is hard. Okay. All right, subsetting. All right, it says R's subsetting operations are powerful and fast. Mastery of subsetting allows you to succinctly express complex operations in a way that few other languages can match. Okay, and it says subsetting is hard, and I would say in the beginning subsetting is hard, but then you get used to it, and then you start thinking in subsetting mechanics. And I'm sure you guys covered some of this in Stats 20. We'll take maybe a little bit of a deeper look at how some of this stuff works. So we'll take a look. Okay, and of course you guys are familiar with the str structure command, which shows you how things are broken out. Okay, so this is probably the most basic way to subset using the bracket notation, and then we also have double bracket for lists and things like that. Okay, yeah, let's take a look. Okay, so as far as atomic vectors go, we use the single brackets and things like that, and you can use integers, negative integers, and then logical and character vectors. So just these demos that I'm using, we'll be using this vector of numeric values, okay? And they're written in such a way that you have 0.1, 0.2, 0.3, 0.4 to indicate this was the first, second, third, and fourth elements. Because, you know, when I subset and rearrange things, it's like, where was that originally? So this will help you keep track of that, okay? So, you know, you got, if you put a number inside the bracket, that will give you the number in that position. So if I say 3, 1, inside, so the I'm providing it a numeric vector, right, with elements 3 and 1. It's going to pull out the third element and the first element. Okay. When I put in the command order, it's going to look at this and it's going to return back the order that I need to use. It's going to say take the first, then the third, then the second, and then the fourth. And then when I subset x in that way, it sorts them so that it takes the first, the third, the second, and the fourth. Okay? So x bracket order inside there is pretty much sort x. Okay? So sorting x puts them in from least to greatest. Order will tell you, which element is the smallest. If you want to know the third largest element, what would you do? You would do order x, and then you would say bracket 3, and it would say, oh, the second element is the third largest element. Okay. Do I need to demo that, or are we good there? We're good. Okay. Well, one person gave me a thumbs up, so that's great. Okay. We have, you can put the same number in there multiple times. So if you say, 1, 1, 1, it's going to return the first element. Okay. So you can, this is often useful if you're going to use things in kind of like a lookup fashion, like a lookup table. And that will come, actually on Monday we'll follow up on subsetting even more. Okay. And then if you ever stick in decimals, they just truncate them and return back the thing. So if you say 2.9 and you're using that as a subset, it's going to just return the second element. Okay, it doesn't return an error. It just says, I'm going to do the best I can with this. and returns this. Perhaps that is what you want, or that isn't what you want. Just watch out for that. Negative integers remove those elements. So -3 and 1 say remove the third and remove the first element. Okay. But you can't mix negative and positive integers because that does not make sense. Right. It says remove the first, but give me the second. You know, what do we do with the third and fourth? It doesn't know. Okay. All right, and then with so you know that's how you subset using numbers. You can subset with logical vectors, so you can return trues and falses, and so you have, you know, if it says true, true, false, false, it will return you the first and the second elements, okay? And it doesn't return the third and the fourth. And because of this, you can subset using kind of these comparison operations. X greater than 3, okay, if we look back to the original value of x, x greater than 3 will return false for the first element, and then true, true, true. Okay? And so when I feed that into here, it's basically subsetting on false, true, 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 and we're getting to just get the elements that are greater than 3. So you can subset using kind of a comparison operation that turns into a logical vector, and it's using the logical vector for that. Okay. Just like before, if you give it something, it recycles the elements. Okay. So here we're telling x to we're giving it true and false, and so it's recycling the true and false, and it goes true, false, true, false, and that's why it's returning the first and the third elements here. Okay, so these two things are equivalent, right? And then if you ever have a missing element, a missing value in your logical, or a missing value in something else, missing value in your logical vector, it's going to return a missing value. Okay, so if we have true, true, missing, and false, it will return the first and the second, and then a missing, an NA, and then it does not return the
how it's recycling the values in the second.
On this one? Oh, it's not recycling this. Okay, so we had 4 values in our original vector x, right? We have 4 values in our original vector x. So this says, give me the first. Do you want the second? False. Do you want the first? Yes. True. I mean, third? True. Do you want the fourth? False. So effectively, it just gives you back the first and the third. There's no recycling here. When you only give it 2 elements, it says, for basically odd ones, give them, even ones, don't. Okay? Yes?
What if your original vector isn't a multiple of your logical vector? Does it become an error?
I think it'll just do it. Let's try this out. Okay, so here let's do x is 1 through 9. Okay, and then we'll have y being true and false. Okay, and then so we'll say x subset on y. It just does it. It doesn't complain. Okay. Let's see if we do this. Let's see what happens here. True, false, NA, true, false, NA, right? Okay. True, false, NA, true, false, NA, true, false, NA. Yeah. Okay. Just recycles the things around. Okay. Okay, special cases, nothing returns the original vector, and then if you put in a 0, it's going to return a 0-length vector. All right, so you put in x bracket with nothing inside, just returns you the original vector. You stick in 0, it'll say numeric 0 because x is a numeric vector. And if the vector is named, you can use character vectors to return elements with matching names. All right, so here we're gonna create y as x, but it now has names a, b, c, and d. Okay, and we can subset y using characters. Okay, give me d, c, and a, and it returns them in that order. So DC, that's like Disney California Adventure now. All right, integer, you can repeat them. So if you say AAA, it'll give you back the first element 3 times. And when you're using this to subset, it has to match exactly. So if we named them ABC and DEF, you can't just say give me A. It's going to say I don't find an exact match there. Okay. All right, lists. Subsetting a list works very similarly. Okay, if you use a single bracket, that will return a list. Whereas if you use the double bracket, you pull the components out of the list. Okay, so here we're creating a list of 3 things: A, B, and C. A is numeric, B is logical, and C is character. And if we say, okay, from list D, give me back the first thing, it returns back a list of A. Okay, it returns back a list with just one thing in it, A. All right, and then, okay, so then we have matrices, okay? So again, a matrix is, yes, question?
Just a quick question with lists.
Yeah.
I don't know if they're named like ABC, but once you run out of the single character, you just go like AA? How does it?
Oh, you can name the list whatever you want. It's just for convenience I've been using ABC, but you can name them Adam, Joe, and Bob.
So it's not like named by default though, is it?
No, well, yeah, it's not. If you don't provide any names, it the first thing will be called double bracket 1. Okay, so yeah, like if I just say list 1 through 10, and then characters A and D. Okay, it says the first double bracket 1, and there's no name associated with it. Okay. Okay, so we have matrices and arrays. So again, a matrix is pretty much an atomic vector with a dimension attribute, right? Okay, and so and you can subset these things with multiple vectors or a single vector, or you can even subset with a matrix. Okay, and I would say the most common way that we're all probably familiar with is when you're trying to subset a 2-dimensional matrix, you give it a kind of 2 coordinates to use. Okay, and then and just like before, when you have a blank, it's going to return everything, and so you can give it basically 1 coordinate, which would correspond either to a row or a column, and it will work that way. Okay, so here matrix A is just the numbers 1 through 9. Okay, if you're having a hard time visualizing, 1 through 9, number of rows equals 3. Okay, it looks like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and and we're going to give it some column names here. All right, I might as well just run this. Okay, and then we'll say column names of A will be the letters A, B, C. Okay, so A is that. Oh, I guess I did capital letters. That doesn't matter. All right. Okay, so if I just say give me back 1:2, it'll return just the first 2 rows. Okay, because when you reference coordinates in a matrix, it's always which row and then which column. Okay, row and then column. So it says give me the first 2 rows, all the columns, and it does that. Okay. Over here, we're giving it a logical vector for the rows, okay? So this will give us the first row and the third row. And then as far as the columns, we want column B and column A, okay? And we can see that's indeed what we get. We get the first row and the third row, and then we get column B and column A. Over here, I'm not sure why you would want to do it this way, but you can, okay? It says give me back none of the rows and remove the second column, okay? And so we get really nothing, but it just tells you, okay, we've got the column headings here, all right? Okay. By default, the single bracket will simplify the results to the lowest possible dimensionality, okay? If you don't want to do this, this is called preservation. But so effectively what this means is that, you know, A is a matrix, right? If I say, is this a vector? It's going to say no. But if I say, just give me the first row, it's going to return this, and this is now a vector. Okay. So it's not, this here is not a matrix with one row. It is a vector. Okay? So it simplifies it. Okay? I could say, and I'll show this later, this preserves, if you want to preserve it in the matrix form and get a matrix with one row, you have to include this thing called drop equals false. That comes later. Okay? But basically, it simplifies it. It says, it turns it into a vector. It doesn't preserve it as a matrix with one row. Okay? Same thing with columns. Okay? So if I say, just give me back the first column, it's now a vector. Okay? And again, if I did drop equals false, this preserves the column nature. All right, so again, you can think of a matrix as a vector with dimension attributes, okay? And so you can subset a matrix using just a vector, okay? So rather, so you know, here I'm creating kind of this grid of just coordinates, right? And if we want this element, and we want, I'm sorry, if we want this element and this element, I can just say, you know, give me back the fourth element and the 15th element, okay? So I don't have to say, you know, give me the fourth row first column and then give me the fifth row third column. I can just say, oh, that's, if I treat this as just one long vector of 15 or of 25 things in it, I can say I just want the fourth element and the 15th element, okay? And so we can get it back this way. By the way, are you guys familiar with the function outer? Okay, so outer, it's totally amazing, and it might be worth just a little detour here, okay? Let's say x we're going to take as values 1 through 5, and y are the elements, we'll do maybe 10 to 50, I think. Okay, so we'll do that, all right? So we have x is 1, 2, 3, 4, 5, and y is that. So if you just do outer, x comma y, the default application is to multiply these together, okay? And so what you're going to do, what you get is, I should, so it's basically taking 1, 2, 3, 4, 5, and then it's multiplying them by 10, 20, 30, 40, and 50, okay? Maybe just to specify, I think I'll do x will be 1, 2, 3, 2, 1, okay? So outer x comma y, so it takes x 1, 2, 3, 2, 1, and then it multiplies each of them by y, okay? And then it doesn't have to be the multiplication function. You can do function equals, I don't know, sum. Why is this not working? function. Oh. Yeah. Inner and outer. Okay. I'm just trying to think of other functions that we use. In the example I used paste. Paste just glues things together. Okay. And so it returns back character strings. And then but I would say, just kind of this multiplication thing. So you give it two things and it's going to create a matrix, right? You give it two one-dimensional vectors, it multiplies them together and it creates a matrix. There's a shorthand for this, and that is %O%. So this is like outer multiply. These two things are the same, okay? And you can even if I did this %O% with, I think I can do this, and it might crash on me. I think this will give me an array, a three-dimensional array. Yeah. Okay. So you can just keep adding dimensions to this structure. You're going to say take x, multiply by y, and create a grid. And if you want to outer multiply it on something else, it'll create even a three-dimensional structure, so on and so forth. Okay. So this is useful if there's like a whole bunch of different combinations that you want it to test out and run across. Yeah.
Do you count column-wise or row-wise? Do you count from left to right or top to bottom when you choose like the...
It counts columns. So it goes 1, 2, 3, 4, 5, and then this element is the 6th, 7th, 8th, 9th, and 10th. This is the 11th, 12th, 13th, 14th, and 15th, so on and so forth. So it just, because if you think of the way R fills out a matrix, it fills it by columns. Okay. Okay, so here we are subsetting a matrix using just a one-dimensional thing by indexing the elements in that matrix, right? So we're basically, rather than using two values to create coordinates, we're just saying this is a atomic vector of 25 elements. So that's one way to do it, okay? And then another way, this is a little bit strange, okay, is that you can use a matrix to subset a matrix, okay? And then so here, I'm giving it coordinates. I'm saying coordinates 1, 1, coordinates 3, 1, and coordinates 2, 4, okay? And so the matrix, this select matrix that I'm using here, if I can highlight this. Oops. Okay. So so the way our select matrix looks like, it looks like 1, 1, 3, 1, 2, 4. Okay, and then so it's written out this way, and it says, create a matrix with two columns, fill it out by row, so that the resulting matrix looks kind of like this. Okay. Otherwise, if you were going to just build the matrix and you did not specify by row, you would have to say 1, 3, 2, 1, 1, 4, right? Which is probably not the way we think, okay? So if we're trying to say, okay, I want coordinates 1, 1, 3, 1, and 2, 4, okay, what it requires is to subset the matrix of two dimensions, we are providing it a matrix with two columns, okay? And then it's going to say, okay, I now know that this column refers to which row, and this one refers to which column you want. Okay, and so when I use subset the matrix vowels with that matrix select, it's going to return back, the items that were in 1, 1, 3, 1, and 2, 4. Okay, and then so if you wanted to subset, a 5-dimensional array, you would provide it a matrix with 5 columns, 1 column for each dimension in that array. Okay. And as far as trying to get elements out of this matrix that are not easily designated by a rectangle, right? So like a lot of times if you are able to draw a rectangle around the elements that you want all together, like a continuous rectangle, you can use kind of the bracket subsetting that we're used to. We can say I just want the second row to the fifth row, and I want the first column to the third column, or something like that. Okay, so if you can draw a rectangle around it, that's probably a good way to go. Okay, well, I mean, even not, you don't have to. You can just say I want second row and fourth row, first thing and first column and third column. Okay, and so I guess it's not a continuous thing, but it's like you're getting those things that you want. If you want something where it's like I want this element and then this element, that's a lot trickier. It's a lot harder to say I only want I want the fourth row and first column, but I only want that thing, and then I want the fifth row and third column, I only want that thing. You can't use it using the standard kind of the most common way to subset. You would have to turn to this kind of using a matrix to select it. Does that make sense? Okay, all right, so anyway, all right. Data frames can behave a lot like matrices, but we have a few extra things that make it easier, okay? Yeah, Bryce.
I just want to make an announcement. I made an error in discussion yesterday saying that you don't have the autocomplete in our markdown. That must have been from a previous version. Now you totally have autocomplete within our RMD file, so like don't just not use it because I told you it didn't exist. It totally. Okay.
Yeah, autocomplete, it's makes your life better, right? And autocorrect also makes your life better. Even though we hate it, it's because it's trying to keep you from looking like an idiot. All right, so but autocomplete, it's the way to go. Okay, data frames, and the autocorrect these days, they're based off of hidden Markov chain models. And so, like, as soon as you say it's going to start filling out all of these other things. It's going to be like doing great, or like it figures out your pattern of speech. All right, not even have to think for ourselves anymore. All right, so we got data frames, and data frames are lists that we've bound together into this two-dimensional structure. Okay, and so most often we'll name the columns in our data frame, but if not, R will do it for you. Okay, and you can subset the columns using the $ notation. Okay, but again, a data frame is effectively a list, so you can use your double bracket notation as well. Okay, to subset a data frame. Okay, and so here we're saying give me back from the original data frame. Okay, we want the thing where data frame $x is equal to 2. So that says look in column X, give me where column X is equal to 2. All right, and that's going to say that refers to which rows we want. Okay, because it's before the comma, and then we have it inside the bracket notation. So that says give me back in data frame form. Don't turn it into just well, we cannot turn it into a vector because we've got different elements here, right? Okay, here it says data frame, we're saying which rows we want. We want the first row and the third row. Okay, and that's what we have here. Okay, and then we can select the columns that we want. All right, we can say give us X and Z. All right, and notice there's no comma here. Okay, why don't I need a comma? Because what's that? Because a data frame is treated as a list, right? So it's treated as a list, and so if I look at this data frame, all All right, this is what it looks like, and I say, what's this? Oh shoot, didn't want that. What's the structure of our data frame? Okay, it's an item. It's a data frame with 3 things. So I could effectively say, just give me back 1, and I'm sorry, 1 and 3. Okay, and that is effectively just give me back the first column and the third column, because a data frame is a list. This is different from a matrix, where if I said 1 and 3, it would turn the matrix into an atomic vector and give me back the first and the third elements there. Here, the data frame is a list, and so it's giving us the first and the third things in that list. So I think that's the biggest difference in terms of subsetting a data frame and subsetting a matrix. If you subset a matrix this way, it would turn it into a one-dimensional vector and give you the first and third elements. Here, it's treating it as a list, and it's giving you the first entire list element and the third entire list element. Okay? So notice we can select columns this way, the way we did with the list. We can also select it by throwing in the comma, and it says, okay, give me all the rows and then give me these columns. This is the way we'd select it as in a matrix, right? Okay, and if you select this single column, the matrix subsetting would simplify into a atomic vector, whereas when you do it with a list, it does not. Okay. So there is a difference doing it these 2 ways. All right. So MT cars, just to let you know, MT cars is a data frame. Oops, not my cars. Motor Trend cars. Okay, and if I ask the structure of MT cars, it's a data frame, 32 objects, so 32 observations on 11 variables. All of our variables are numeric. Okay. What will happen if I try to subset it like this? MT cars, where the rows are MT cars, cylinders equal to 4. Double equal, right? You need the double equal. Okay. What about this one? It says -1 through 4. Yeah, you can't mix in the negatives and the positive things here. Okay, so we got 1 through 4. That just gives you the first 4 rows. Empty cars, give me back where cylinders is less than or equal to 5. Yeah, we need the comma to say I want the rows where this number of cylinders are less than or equal to 5. Okay, and then that will work. I want where the cylinders is equal to 4 or 6. Yeah, we have to say I want where cylinders is equal to 4 or where cylinders is equal to 6. Okay, and then that will return 6-cylinder. There's an RX-4 wagon? Huh. Okay. I don't. All right. Empty cars 1 through 20. There's only 11 columns, so that's gonna error out, right? So if I say 1 through 20, it either has to be rows 1 through 20, or if I'm using this to refer to which columns I want, then I can only say like 1 through 11 or 2 through 6 or something like that, okay? Something within the range of the number of columns that we have. All right, so if I did empty cars, oops, 1 through 20, it's going to say undefined columns, right? But 1 through 11 works. That gives me back the entire data frame. All right. As far as lists goes, or actually not lists, you can even do double frame with vectors. Okay. We've got the double bracket, all right, and the $sign. Double bracket and $sign are pretty much the same thing, okay? $sign is like a shorthand for this, okay? When you use the double bracket, it extracts what's inside the list element, okay? Whereas when you use the single bracket on a list, if you use a single bracket on a list, it's going to return a list with that thing, okay? So this is a good analogy, okay? So if you think of a list, you've got a list of X, and you've got think of it as the different list elements as train cars, okay? Then double bracket 5 will refer to the object that's in train car 5. Whereas single bracket 5, okay, or single bracket 4 through 6 will return the cars 4, 5, and 6, okay? Or single bracket 5 will return the box 5, okay, and the stuff inside. So if you just want the stuff inside, you've got to use double bracket. Okay, so let's say you've got this as our list. If you ask for double bracket 1, it's going to return, it's going to simplify this. It's not going to return a list. It's going to return what's inside, which is 1, okay? And then you can also use characters to subset it that way, and that will work as well. All right, and then so in general, you know, a lot of times things get simplified into kind of their more easier structure, okay? Whereas if you use this thing called drop equals false, it's going to preserve it's going to try to preserve the structure of the object itself, okay? And so sometimes if you're running into problems, it's because you're not using drop equals false, and it's suddenly turning what you thought were matrices into simple vectors or something like that, okay? So, and you can use double bracket on a plain old one-dimensional vector, okay? Same thing, so for lists, this is probably the most common use where we use the double bracket. Double bracket will return you what's inside that list thing, whereas single bracket will return it still in list form, okay? With a factor, the default setting is to preserve, whereas if you want it to simplify the factor, you would apply drop is equal to true, okay? But in general, when you're applying it to some kind of matrix, okay, it will simplify from a matrix into a one-dimensional vector. If you want to keep it as a matrix with one row or a matrix of one column, you've got to include this other option, drop equals false. All right, and then with a data frame, double bracket or something like this, this will simplify it, whereas otherwise you keep drop equals false. Okay, so if you use the double bracket on an atomic vector, effectively what it does is it just gets rid of the names, okay? Otherwise it will preserve the name in there. Okay, with the list, if you use just the single bracket, it returns you a list. Double bracket, it simplifies it, returns you a vector. Okay, and then with a factor, if you say drop equals true, the default setting in factors is that it does not do this, okay? Is that with a factor it will generally keep all of the levels even if you've simplified it, even if you've subset it, whereas if you say drop equals true, it gets rid of any levels that aren't being used. I would say this is not a very common thing that we do. Okay, as far as yeah, matrices or arrays, if the resulting thing has a has a dimension of 1, or I'm sorry, the dimension has a length of 1, it's going to drop that dimension. So if you subset the matrix, you keep drop equals false, it's going to preserve it as a row matrix, whereas over here it returns it as a vector. Okay, and then with the data frame, if the output's a single column, it's going to return a vector instead of a data frame when you do that, right? So data frame, if we say we just want the first column, it's going to preserve it as a data frame. Whereas if we do double bracket on the data frame, it's going to return just the elements there as a vector. Okay, and then again, the $ notation is like a shorthand for double bracket. So when you use data frame $ something, it effectively turns it into an atomic vector. Okay.
Wait, can you say that one more time? The dollar sign is a shorthand for?
So the $ is $ is a shorthand for double bracket.
For double bracket.
Yeah. Yeah. Okay. So yeah, $ right here. $ is a shorthand operator where x $y is equivalent to x double bracket y. All right. And then and the thing here is that it doesn't require you to spell things perfectly, okay? Or it doesn't have to be an exact match. Whereas before with names often requires an exact match, it does not require that. And okay. Oh, this is if you try to do it this way, like if you have variable var is equal to the character string cylinder CYL, this is not going to work because there's no column named var. Whereas, so you'd have to use empty cars double bracket var. Otherwise, you would just use empty cars $ cylinder. Okay. Partial matching works. Okay. Whereas if it's named ABC and you use $A, it'll match. Whereas if you did double bracket A, it's not going to match. Okay. And then this will often be the source of some of your gripes as you're working along. You know, you create a loop and you're saying, I want you to go through the indices of each column in your data frame or each row in your matrix or whatever it might be. You end up going out of bounds, right? So what that means is if you have a 10 by 20 matrix, right? 10 rows, 20 columns, and for whatever reason you're iterating in a loop or something, and you're telling it, now go to the next thing, and it tries to go to the 21st row, or 21st column, or the 11th row, or something like that. That's an out-of-bounds error, okay? And so that R will throw an error. It'll say out-of-bounds and things like that. Error, whatever, out-of-bounds. Okay, so the behaviors of these things sometimes are a little bit different when you end up going out of bounds, okay? So if you do it with an atomic vector, you only have 1 through 4, and you say, give me the 5th element, it's going to say missing, okay? If you say, give me some missing thing, it's going to give me missing, but where if you throw it the null value, it's going to give you a vector with length 0, okay? And so here's kind of like a little thing of what's going to happen when you give it out-of-bound operators, whether it's in a single bracket or double bracket. It'll either kick back an error or give you empty lists or missing elements, okay? And then and then you can do assignment with subsetting operations as well, okay? And so I guess you guys can just look through this because we're out of time here. All right, so just look through the notes on these examples. I think they're pretty self-explanatory here. All right, we'll see you guys on Monday. Have a good weekend.